Okay, hello again. This is Mr. Yo here. So this time round, we'll be looking at worksheet 11.2. If you have not done so, do write down your name and your class and your date, and we shall begin. Okay, so let's look at the introduction. So first thing first, the nth term of a sequence is called the general term of the sequence. This is sometimes denoted by the symbol Tn. In other cases, you can see other letters being used, for example, Pn, Qn, so on and so forth. Alright, but for the purposes of this exercise now, we'll be looking and using the symbol Tn. So let's look at example 1. Okay, the general term of a sequence is Tn equals to n plus 2, n times n plus 3. So we are being asked to find its second and ninth term. Well, it's not too difficult to find the second term. Basically, what you're doing is you are substituting n equals to 2, okay, into the expression here. So let's substitute n equals to 2. So here 2 bracket 2 plus 3, and that's just 2 times 5. 2 times 5 gives you 10. Okay. Now to find T9, well, all we're doing is we're substituting n equals to 9. So T9 is just equals to 9 times 9 plus 3, which is 9 times 12, so you'll get 108. Okay. So let's look at example 2 now. Consider the sequence 4, 7, 10, 13. Find its general term for part A, and part B, hence find its 15th term. You can refer to page 58 of the textbook for illustration, but here there is also a solution which we are going to use. Let's look at the pattern over here. You have T1 is equals to 4, T2 7, T3 10, and T4 equals to 13. And you notice that there is an addition of 3 each time round. Right? So from here you must be able to obtain the general term. Well, what I generally like to use is by looking at the number here. So if there is by looking at this number over here. So for instance, this number over here is a 3, which means that when I want to do my Tn, this number 3 is the coefficient in front of n. So I'll be putting in 3n first. But then what I realize is that when I substitute in n equals to 1, I get 3 times 1, which is equals to 3. But I do need a 4 over here. And therefore, I will have to add a 1 in order to get 4 for my first term. So this will be the answer that we are looking for. Okay, this is a method that's alternative to the one that is being shown over here. Alright, so in this case, what they're doing is they're splitting it up. Okay, and they observe that there is a number that is changing, which is multiplied by 3. Alright, so in the first term, you have 1 times 3, second term 2 times 3, third term 3 times 3, fourth term 4 times 3. And this number is changing. Well, the number 1 is a constant throughout. So therefore, you end up with Tn equals to 1 plus 3n. Alright, so in both methods, you will end up with the same answer. But I will generally prefer to use my method throughout the rest of this worksheet. Okay, so let's move on. For 1 part B, T15 will be 1 plus 3 times 15, which means you have 1 plus 45, so the answer is 46. Okay, now I would like you all to move on to page 2 and look at the activity-based learning. Once again, as in the previous worksheet, I want you all to read through the question, try it out yourself first, press the pause button, and then once you're ready, play the video to look at my solution. Okay, so let's look at part A. Here they're asking us to draw a diagram to show the arrangement with chairs when 4 tables are placed together. I don't think it's too difficult. Basically, the tables are placed horizontally, so the pattern is such that we will carry on doing so. So please use ruler and pencil to draw the tables and a pencil to draw the chairs. Any drawing should be done in pencil. So let's draw the arrangement with chairs when 4 tables are placed together. Okay, my first table, second table, third table, and fourth table. And I'll be labeling them 1, 2, 3, 4 as being done in the examples given above. And then my chairs are labeled using circles and lines. Okay, so count the number of chairs, and in this case you should get 10. Right? So what's the pattern here? How are you gonna get the next row for 5 tables? Well, let's look at the first 4 numbers that we have. From 4 to 6, we are adding 2. 6 to 8, we are adding 2. 8 to 10, we are adding 2. So how are we going to get the next one? Well, we just carry on with the pattern to get 12. Take note that in the last row, you are finding the number of chairs for 100 tables. Are we going to draw it all out? That's going to take up a lot of time. And so, trying to identify the pattern will be something that will save us a lot of time and be a lot more useful. So what's going on here? Notice that, well, what's happening is that in the first figure, you have 4 chairs, right? In the second figure, all you're doing is adding on 2 more chairs. Okay? This third figure, another 2 more chairs. Fourth figure, another 2 more, so on and so forth. So, how many chairs do we add on from the first table till the 100th table? Well, in this case, what you're going to do is, you notice that there are 99 tables that have been added on. So, for each additional table, you are adding on 2 additional chairs. Meaning to say, you need to add 2 times 99. Alright, so once you have done that, 4 plus 2 times 99, you will get the answer 202. Okay, so let's look at part C. Is there a pattern for Cn? Definitely. And if you did not rely on drawings, what did you do to get the number of chairs needed? Well, like I mentioned earlier, we add 2 chairs for every additional table after the first one. Right? So, how are the values of n and Cn related? Express Cn in terms of n. Now, take note of this phrasing. What they are asking us to do here is to find the general term or general formula. Alright, and so you notice that the number 2 is the one that's being added each time round. Right? So Cn, 2 will be the number that is in front of the letter n or the coefficient of n. And then, well, we notice that the first table, you have 4 chairs, right? So, if you were to substitute in n equals to 1, that only gives you 2. Therefore, you need to add another 2 more chairs. So now, in this case, when n is equals to 1, you have 2 times 1 plus 2, that gives you 4. And that satisfies the general term that we are looking for. Okay, so in part E, write down the number of chairs needed when 18 square tables are placed together. So in this case, will bring us to find C18, which is 2 times 18 plus 2. So 36 plus 2, that gives you 38. Is it possible to have 50 chairs that follow this pattern? Well, now what we're being asked to find, okay, possible to have 50 chairs that follow this pattern, meaning to say we're looking for the number of tables. Okay, so therefore, what we are actually trying to find is the letter n, right? So we have 2n plus 2 is equals to 50, and therefore we need to solve for n. So make n the subject. 2n is equals to 48, and so n is equals to 24. Therefore, 50 chairs are needed. Okay, yes, it is possible. 50 chairs are needed. Okay, when 23 square tables are placed together. Okay, so now let's move on to the next page. Okay, let's work through this. Let's try question together. So here the diagram below shows the first tree of a sequence of dot patterns. Part A, the information from the sequence of dots is tabulated below, and we need to draw the fourth and fifth pattern and then complete the table below. So, well, just very quickly look through these three patterns and let's draw the fourth and fifth ones. So you can tell that as the number gets larger, you have more dots are increasing in the up, down, left, right position with respect to the center dot. Right? So in the third one, in the third pattern, you have 2 on the right, 2 on the left, up and below. So the same thing is going to happen for the fourth one. Alright, you're going to have 3 now on the right and 3 on the left of the center dot. Alright, and then 3 at the top and 3 at the bottom. And you should be able to guess by now that for the fifth pattern, with respect to the center dot, you're going to have 4 on the right and 4 on the left. Right, let me just make it clearer over here. Okay, so the same thing is going to happen for the top and for the bottom. Make sure you have enough space to draw your patterns. Try not to draw it such that it's in between any of the words like I've done so here. So make it neater if you have to. Let's move on. Okay, so let's fill in the table over here by just counting up the dots. You will have 13 and 17, and then filling in the formula, just following through the pattern. You will have 1 plus 4 plus 4 plus 4, and 1 plus 4 plus 4 plus 4 plus 4 for the last row. Alright, so now we are supposed to find a formula. Alright, and this is the general formula or the general term to calculate the number of dots in the nth pattern. I'm going to use my method. Alright, so you can see that there is an addition of 4 each time round. Okay, and what this means is that this number here will be the coefficient of n. So I will write 4n first. Alright, now notice that if you have 4n and n is equals to 1, then you're gonna get 4 times 1, which is 4, but you want 1, therefore you need to subtract away 3. 4n minus 3 will be the correct pattern. Okay, so just check it. When n is equals to 2, 4 times 2 equals to 8 minus 3, you get 5. When n is equals to 3, 4 times 3 is 12 minus 3, that's 9. Okay, and you can check the next few cases if you want to. Alright, so now we are supposed to find the number of dots in the 25th pattern. That just means n is equals to 25. So do the substitution. 4 times 25 minus 3, that will give you 100 minus 3, that's 97. Now find the value of m. Okay, if there are 501 dots in the m pattern. So take note, we are not using n anymore, we are using m. So 4m minus 3 equals to 501. Make m the subject by adding 3 to both sides. So 4m is equals to 504, and therefore m is equals to 126. Okay, let's flip over to the next page. On page 4, can you now take the time to try out mastery practice in the same way? Read through the question, do the question, put a pause on the video, and then once you're ready, press the play and check through and see whether your solution is correct. Okay, so I'm gonna carry on and draw the 4th pattern now, and the 5th pattern after that. So, well, let's take a look at this. In the 2nd pattern, there are 2 dots, okay, on the left and on the right, 3 dots on the left and on the right for pattern 3. So you would expect the same thing for pattern 4. For the pattern 2, you have 3 at the bottom. For pattern 3, you have 4 at the bottom. Alright, so this should be enough to tell you what should be pattern 4. So 4 on the left first, 4 on the right, and then 5 at the bottom. Okay, please make sure that you draw them in a way that is aligned, otherwise it doesn't look like it should be the correct pattern. So for the 5th one, you will have 5 on the left, 5 on the right, and then 6 at the bottom. Alright, as in the let's try question, basically count the dots and fill in the table accordingly. So 13 and 16. Now here the formula, if you were to refer back to the first pattern, this one will give you 4. Notice that this is just 4 plus 3, and then you are adding 3 subsequently for each additional row. Okay, so now we have to write down a formula to calculate the number of dots in the nth pattern. Again, you are adding 3 to get the next number, and this number should be the coefficient in front of n. So you're going to start off writing 3n, and then you're going to have to figure out what's the number that you have to add in order to get your desired number when n equals to 1. So here when n equals to 1, you have 3 times 1 is 3, and you want to get 4, so you need to add 1. And then check through again. When n is equals to 2, 3 times 2 is 6 plus 1, you do get 7. 3 times 3, 9 plus 1 is 10. And so this is the correct pattern after all. You're being asked to write down the number of dots in pattern 30. So here in this case, this just means that n is equals to 30. So do the substitution and you will get the answer that you are looking for. So 3 times 30 is 90, 90 plus 1, 91. Okay, I will skip the what's the question in the box. This should be an activity that your teacher will carry out in the class. Spend the time to think about it. There may be more than one possible answer in this case. Let's move on to the next part. The next page, the let's try. Alright, now the general term here is slightly more complicated. There are 3 terms here, and there is even a squared term inside. Alright, and then you are adding in other terms as well. So here, find the first and the 10th term. Well, not too difficult. Just substitute in n equals to 1 and n equals to 10 respectively to get your answer. So t1 is equals to 1 square plus 2 times 1 minus 1. This is just 1 plus 2 minus 1. You get 2. And t10 is 10 square plus 2 times 10 minus 1 equals to 100 plus 20 minus 1. So you get your answer 119. Alright, let's try the mastery practice yourself first. Press pause on the video, and once you're done, press play to see my solution. So now in this case, you're being asked to find the values when n equals to 2 and when n equals to 9 respectively. So t2 is just 2 times 2 plus 3, that's 2 times 5, which is 10. T9 is just 9 times 9 plus 3, which is 9 times 12, 108. Alright, let's try question 2. The general term of a sequence is now Tn equals to n times n plus 1 over 4, and you need to use this formula to find T20. So that means to say n is equals to 20. So T20 is equals to 20 times 20 plus 1 over 4. If you can't do this mentally, then press your calculator to get your answer. You will end up with 105. Now, find the value of m whereby Tm is equals to 60. Well, let's just rewrite what Tm is supposed to be. Tm is just basically replacing n with m. So instead of writing n times n plus 1 over 4, I will be writing m times m plus 1 over 4 equals to 60. Alright, so how are we going to solve for the value of m now? Well, let's multiply by 4 both sides. So we have m times m plus 1 equals to 240. And, well, what do we notice about m times m plus 1? Well, here, m and m plus 1, they are basically two consecutive numbers, right? Not just two consecutive numbers, they are two consecutive integers. Okay, so let me just put a note down here. So we are looking for two possible consecutive integers. When multiplied together, the product gives you 240. Alright, so do this by trial and error. Obviously, the numbers can't be too big. And you will end up with m equals to 15. Alright, because 15 times 16 gives you 240. Okay, when you are in Sec 2, you will learn a method where you will be able to solve this without using the trial and error method. But meanwhile, this is the only way that you know how to solve this problem. Okay, so now we've come to the end of worksheet 11.2. So complete your homework by the next lesson, and your teacher will go through the questions in class.